Welcome to The Explainer. Today, we're going on a journey climbing this really interesting ladder that shows how AI is learning to go from just, well, seeing the world to actually understanding it.
It really all boils down to this one huge question. How can we make AI smarter? And I don't just mean faster at processing data. I mean truly more intelligent, more perceptive about the world around us. This is one of the biggest puzzles in AI right now, and we're going to break down how we start to solve it.
When we talk about AI perception, it's easy to just think about it slapping a label on something, right? But there is a massive difference between an AI seeing an object and genuinely understanding what that object means. It's kind of like how our own brains work.
I mean, think about it. When you see someone across the street, your brain doesn't just register, yep, that's a person, and then stop. No way. You immediately, almost instantly, start adding layers of context. You're asking, okay, are they a soldier or a civilian? And based on what they're doing, are they a friend or maybe a threat? It's this multi-layered thinking that we're trying to build into AI.
Okay, so let's start claiming. The first rung on our ladder, this is where you find the most common type of perception AI out there. We'll call it the generalist, the jack of all trades. So this is what's often called an integrated AI. It's this single giant model that's been trained to recognize basically everything all at once. It's trying to spot people, cars, buildings, animals, the whole shebang, all using just one brain. Now, the upside here is that it's pretty simple to set up, and yeah, it's versatile, and this is a big but. By trying to be good at everything, it ends up not being truly great at any one thing. The accuracy is often pretty low, it's terrible with fine details, and it gets confused. A lot. When you're trying to tell the difference between a person, a tank, and a tree all at the same time, things can get messy.
And that problem, that lack of precision, brings us to the second rung on the ladder, the specialist. This approach is all about solving the generalist's accuracy problem. This is the master of one. We're talking about a custom AI. So instead of knowing a little about everything, this AI becomes a world-class expert in one very specific thing. For example, you could train a model that does nothing but identify soldiers. It's completely obsessed with that one job and ignores literally everything else.
So the trade-off here is pretty dramatic. On one hand, you get absolutely incredible precision, super high accuracy, very few mistakes. But on the other hand, it has zero, and I mean zero, versatility. That expert AI that can spot a soldier from a mile away, it is completely blind to the tank that soldier is standing right next to.
And this right here, this is the core dilemma we're facing. You're kind of stuck, right? You've got the generalist AI, which sees everything but can't be trusted on the details. And then you have the specialist AI, which is super precise but has extreme tunnel vision. So how do you get the best of both worlds?
This is where we get to the top of the ladder. This is where things get really, really clever. It's not about choosing one or the other. It's about building an expert team. This is the hierarchical approach. I absolutely love this way of thinking about it because it just clicks. You can imagine a smart manager leading a team. The manager doesn't try to do every single job. Of course not. The manager sees the big picture and then delegates the right tasks to the right expert on the team to get the job done properly. So here's how that actually works. First, a top-level generalist AI makes a broad observation, like, okay, I see a person. But it doesn't stop there. It acts like that manager and delegates the task, asking a specialist AI, hey, human expert, is this person a soldier or a civilian? And if that specialist comes back and says soldier, the manager can go even deeper and assign another expert to figure out their affiliation. All these layers of analysis get synthesized by that top-level AI, which then makes a final, comprehensive, and deeply informed judgment.
And the results? Well, they're pretty amazing. This hierarchical system delivers incredibly high accuracy and reliability, both over 90%. But for me, the real game changer is that third bar. Interpretability. Because the decision is made in these clear, logical steps, we can actually trace the AI's logic. We know why it made the decision it did. It's not some mysterious black box anymore. And that why gives us a solid, trustworthy foundation to make our own judgments.
So this table is the perfect recap of our climb of the ladder. You have the integrated model, versatile but sloppy, The custom model, precise but has tunnel vision, and then the hierarchical model, which takes on more complexity in its design, but in return, it achieves what the other two can't, both incredible accuracy and sound judgment.
So where is all of this headed? What's the end game? Well, it's all about pushing AI into a truly intelligent future, one that goes way, way beyond just seeing. At the end of the day, the goal isn't just to build a better camera or a simple seeing machine. The real ambition here is to create an intelligent partner, an AI that doesn't just show us what's there, but actually helps us understand what it means and gives us that critical evidence to make better, faster decisions. And building this intelligent partner really comes down to these three key ingredients. You need those precise, custom AIs, the specialists. That's about 40% of the work. Then you need the hierarchical system, the smart manager. That's another 40%. And that final 20% is something called multi-agent synthesis, which is just a fancy way of saying you bring all those expert opinions together into one single, coherent, and meaningful conclusion. And that really leaves us with this one big, crucial question to think about. As we design the next generation of AI, what are we actually trying to build? Is the goal just a machine that sees the world for us, or is it a true partner that helps us understand it? The answer we choose is going to define the future of intelligence itself.